Welcome in .core. Do galaxies spin randomly, or is there a hidden pattern in the universe? New result from the James Webb Space Telescope suggests more early galaxies spin one way than the other, challenging core ideas of cosmology. In this video, we'll dive into what JWST uncovered, why scientists are cautious, and how spinning galaxies could change everything we know about the universe. The discovery of the James Webb Space Telescope, designed to observe the faintest light from the earliest galaxies, has given astronomers an unprecedented window into the first few 100 million years after the Big Bang. Using its sharp infrared images, a research team from Kansas State University studied a sample of 263 galaxies from that early era. The question they asked was whether these galaxies showed any preference in their direction of rotation. According to the cosmological principle, the universe should appear the same in all directions on large scales. That means galaxies should be roughly split between clockwise and counterclockwise spins with only small variations due to chance. But the results were clear. Out of 263 galaxies, 158 appeared to rotate clockwise, while 105 rotated counterclockwise relative to the Milky Way. The imbalance was not subtle. In fact, the researchers noted that anyone looking at the images could see the difference without needing complex calculations. This isn't the first time astronomers have noticed hints of a pattern in galaxy spins. Previous ground-based surveys had detected smaller asymmetries, but they could easily be dismissed as noise or local effects. What makes this case different is that JWST can look much farther back in time. If the same imbalance existed in the earliest galaxies, then it may point to a fundamental property of the universe itself rather than a local quirk. The result doesn't yet prove a universe as a preferred direction, but it does raise a question that cosmologists cannot ignore. Could there be an underlying axis of the cosmos visible in the way galaxies spun billions of years scientific importance and theories ago? The significance of this finding lies in what it challenges. The cosmological principle is one of the cornerstones of modern cosmology. It assumes that on the largest scales, the universe is homogeneous and isotropic. Essentially, that no place or direction in space is special. This principle is built into the standard model of cosmology, which explains the Big Bang, cosmic inflation, dark matter, and dark energy. A preferred direction of galaxy spin would break this assumption. It would mean that the universe is not completely isotropic after all. If that's true, many of the models we rely on would need revision. Several explanations are being considered. One is that the universe itself may have been born rotating. In that case, the early spin could leave behind a detectable pattern in the orientation of galaxies. This idea connects to a speculative framework called black hole cosmology, which proposes that our universe could exist inside the event horizon of a massive black hole in a larger universe. In this view, the rotation of the parent black hole might leave an imprint on our own cosmos. Another possibility is more mundane but still significant: observational bias. If galaxies rotating opposite to the Milky Way appear brighter due to Doppler effects, they might be easy to detect. That could skew the data, making it look as though there's an imbalance, when in reality, the distribution is closer to even. If this is the case, then many of our cosmic distance measurements may need recalibration. Other models such as an ellipsoidal universe or dipole Big Bang allow for large-scale asymmetry without invoking black holes or observational errors. While less radical than black hole cosmology, these models still challenge the neat symmetric picture we've relied on for decades. Implications and what's next if these results hold up. They would reshape some of the most basic ideas in cosmology. The assumption of isotropy is embedded in nearly every calculation of how the universe expands, how galaxies cluster, and how cosmic structures evolve. A preferred axis would mean rethinking those foundations. For example, the idea of a rotating universe or one born inside a black hole would move from speculation to serious scientific consideration. Such a model could also provide new ways to think about the Big Bang not as a singular beginning but as the interior view of a collapse event in a larger reality. Even if the explanation turns out to be observational bias, the consequences remain important. If light from galaxies is being misinterpreted, then many of our measurements of cosmic distances and ages may need to be recalibrated. This could help resolve puzzles like the Hubble tension, the disagreement between different measurements of the universe's expansion rate. It might also explain why some galaxies in the early universe appear larger and older than our models predict. The path forward is clear: more data, JWST has only begun to probe the distant universe, and additional surveys will either confirm or challenge the pattern. Other instruments like the Nancy Grace Roman Space Telescope and the European Extremely Large Telescope will add further precision. These will allow astronomers to test whether the imbalance is consistent across the sky or confined to certain regions. At the same time, theorists will refine models and simulations to see which explanations best match the data. Whether the answer comes from exotic physics, subtle biases, or a combination of both, the process will push cosmology forward. Outro JWST has revealed a galaxy spin imbalance that challenges our view of the cosmos. The story isn't finished, but even the smallest details can reshape our understanding of the universe. Stay curious and subscribe for more space discoveries. Thanks for watching.